All right, this is section 3.1. Okay, and this is going to be all about graphing quadratic functions. Okay, quadratic function is any function of the form ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Okay, so this should look familiar. Okay, this is standard form of a quadratic. And a quadratic function is a polynomial whose highest power is 2. So the highest exponent you'll have is 2. And the graph of a quadratic function is called a parabola. Okay, so we are going to be graphing parabolas here, and we are going to use ABC form to graph these. All right, so there's a couple of things that you'll need to know. You'll need to know, first of all, what your form should look like, ax squared plus bx plus c. That's what form you need your function in to be able to use this. Then you'll need your vertex. Okay, that's very important. I'm going to do that in red, right? Your vertex is very important. You're probably going to need to find that every single time. So let's see. That form is, or that formula is negative b over 2a is your x value, and f of negative b over 2a is your y value. So you'll find negative b over 2a by plugging in b and a, and then whatever number you get, you'll do f of that number to find your y value. So you're going to plug in whatever number you get here for x in your form, okay? And you'll get your vertex. Your axis of symmetry is x equals negative b over 2a. You'll notice that that is the same as your x value, okay? So once you find your x value to your vertex, you found your axis of symmetry. And then you will need to know that if a is greater than 0, your parabola opens up. And if it's less than 0, your parabola opens down. Okay, so 3 pieces of information. You'll know your vertex, your axis of symmetry, and whether or not it opens up or down. Okay, so if you have something that looks like this as a parabola, okay, they'll look like U's. This, draw it again. And here would be your vertex. Here would be your axis of symmetry. Okay, your axis of symmetry will split your parabola in half. Okay, so if I folded this part over this line, it would land exactly on top of this line. Okay, that's what symmetry means. So that would be your axis of symmetry. Okay, so knowing all of those things is very important. All right, so let's do some examples. So it says graph by finding the vertex, the axis of symmetry, and max or min for the given function. 2x squared plus 4x minus 3. Okay, what form are we going to use? We're going to use ABC form. Okay, that one's an easy question. What is the vertex? Okay, so I'm going to go down here and do it. The vertex. Okay, we have our vertex is negative b over 2a. That's our x value, and then our y value is f of negative b over 2a. Okay, so let's find our x value first. X value, okay. Negative b, so we'll have x equals negative b over 2a. Our b is 4, and we'll make it negative over 2 times a, and our a is 2. So we get negative 4 over 4, which is negative 1. All right, that's our x value. So it would look like this, and we have a question mark with our y value. So now we're doing f of that number, okay? So we'll plug into the function. Okay, we're plugging x equals -1 into our function. So we're saying f of -1 equals 2 times -1 squared plus 4 times -1 minus 3. So wherever there was an x in our function, we plugged in -1. So we get 2 times 1 minus 4 minus 3, which is 2 minus 7, which is -5. Okay, so we have, that's supposed to be negative. -1, 5 as our vertex. Okay. I'm just highlighting it so I remember where it's at. -1, comma 5. So I'm going to fill that in up here, -1, comma 5. What is the axis of symmetry? Okay. If you look back, you'll see that your axis of symmetry is the same as whatever your x value was that you found for your vertex. Okay. So I'm going to star it and write it in purple up here because it's the same. So x equals -1. Okay, and A, I'm going to do a different color. A, which is in your function, it's your first value, is 2. That is positive. That's greater than 0. So the graph opens up. So it's going to look something like this. And I knew that because 2 was positive. And then it says pick additional points close to the vertex, okay? Pick additional points close to the vertex. So let's go ahead and mark our vertex. We're -1, and then, am I supposed to have a -5? Yep, you'll probably call that, and I did not. We got -5 for our vertex, so I'm just going to go in and write a negative. That is not bad. -5, -1, -5 is our vertex. That's my fault. Okay, we need to pick points close to the vertex. Okay, well, it's always going to make sense for you to pick the x value of 0. Okay. If you pick x equals 0, then you're going to plug in 0 for x in your function. Okay, so you can always pick 0 if it's not on the axis. Okay, so let's pick, whoops. And then plug into function. Okay, so if we have x, y, our x is 0 on our little t-chart over here. So we're doing f of 0 equals 2 times 0 squared plus 4 times 0 minus 3. Okay, so we get 0 plus 0 minus 3. So we get -3. So an additional point that we can plot is 0, -3. Okay. Now let's label our axis of symmetry. And we know it's going to go right between that vertex. I'm actually going to, there we go. Okay. So we know a little something about parabolas because of our axis of symmetry. Okay. We can't quite draw our parabola yet because we know that this line goes like this, but we don't know what this one does. Does this one go here? Does it go way out here? What about here? We do know because of the axis of symmetry. Okay, so if this is this line, and we know this is how it goes, and we know that this point exists because that's the additional point that we plugged in, because it's symmetrical, we can go across from here. So here we are at our line of symmetry, okay? And we're in line with that extra point, and we can go 1 over and line those up, and that is where it's going to be because it's symmetrical. So we've got to be able to fold this gray line over here, and it should lay on top of this line. The only way that's going to happen is if these 2 points are equidistant from our line of symmetry. Okay, equidistant just means an equal amount of distant from one another, or from the line of symmetry. Okay, so this one was 1 this way, so we went 1 this way and marked it and drew our line. Okay, and then you need max or min occurring at what point. All right, so you're looking, whoops, almost erased it. You're looking this way, up and down. Okay, this one is going to have a minimum because our maximum is infinity, right? This graph is starting right here, this parabola starting right here, and it's going all the way up, 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 forever and ever. Okay, so this has a minimum at, okay, so I'm going to circle minimum. I'm going to do it in a different color. Minimum at the point -1, -5. So at the vertex, your vertex is going to be your max or min. If it opens up, you'll have a minimum. If it opens down, you'll have a maximum. Okay, so that is a lot that we can tell. A lot of questions that we can ask just from our one function. Okay. All right, let's do another one. Same questions that we're asking ourselves. What form are we going to use? That's an easy question. ABC form. What is the vertex? Okay. All right, again, that's -b over 2a and f of -b over 2a. All right, so we'll do our x value first. Okay, x equals -b over 2a. All right, b is 4 again, so we'll say -4 over 2 times a. A is, let's go look. All right, there is an understood 1 right here. So a is -1. And we are left with -4 over -2, which is 2. All right, so we have 2 comma something. So now we need to find our y value. And for our y value, we're going to plug in 2 to our function. So we have f of x is equal to -1x squared plus 4x minus 4. And we're going to find f of 2. -1 times 2 squared plus 4 times 2 minus 4. So we get -1 times 4 plus 8 minus 4, which is -4 plus 8 minus 4, which is 0. Okay, so we have 2, 0 as our vertex, 2, 0. And so we can just go ahead and mark that. I'm going to go over 2 up 0, so right there. All right, what's our next question? What's the axis of symmetry? Okay, we know that that's going to be the same thing as our x value that we found. Okay, this is, I'll star it and write it in blue up here. So we have x equals 2. All right, so we know we're going to have this line dot. All right, so we're going to be able to fold our parabola in half on that line. All right, a equals blank, so the graph opens blank. All right, a equals -1, so our graph opens down. Okay, so we're going to have something that looks like this. All right, and the reason for that is that a is negative. All right, now we need to pick additional points. We are just going to go with 0, plug in x equals 0. So our x and our y, we have 0. F of 0 equals -1 times 0 squared plus 4 times 0 minus 4 is 0 plus 0 minus 4, which is -4. So our additional point is the point 0, -4. So we can plot that 0, -4 right there. Okay, and because of symmetry, we can plot another point directly on the other side of our axis of symmetry, okay, in line with that 0, -4. All right, so this is 1, 2 away from the axis of symmetry, so we're going to go 1, 2 this way and make that a point, and then draw our parabola. And there it is, okay? All right, so we need to find our max and our min, and it's at what point? Okay, I told you that your max and your min is going to be your vertex, okay? And this is a maximum because our graph starts, okay, if we're going from down to up, it's going to start at -infinity and come all the way up to our vertex, okay? So we have a maximum, and it is at our vertex, which is the point 2, 0. Okay. So I can give you these questions in a bunch of different ways. One of the ways is like we just did, I can ask you all the things about them. Another way is for you to have to choose the correct graph. So I can give you a function and I can say, okay, pick the right graph that goes with it. Those are obviously going to be a little easier, okay, because you can use some process of elimination there. Immediately, I can look at this problem and mark out 2 of them. Okay, the a value is negative. That means that my graph will open down. Okay, so make yourself a little note. A equals -1. So graph opens down. Okay, in our options, we have 2 that open up. So those are not it. Okay, so we're stuck between these 2. You can look at these 2 and say, okay, they have different vertices. Okay, this one's over here, this one's over here. So if I find the vertex, then I should be able to pick the right one. Okay, so let's find the vertex. Okay, x equals negative b over 2a. So so it's already negative, so I'm going to make it positive. So it's going to be a positive 4 over 2 times negative 1, which is 4 over negative 2, which is negative 2. I'm going to plug that value in to our function. So f of negative 2 is going to give me something that looks like this. Okay. So I get negative 1 times 4 plus 8 plus 5, which is 9. All right, so my vertex should be negative 2, 9. So I'm going to go up here and see which one is negative 2, 9. So we're going to go over to negative 2 up to 9. So this one has the correct vertex. This one does not. So our answer is B. All right, so much easier there. You didn't have to find everything because I already gave you the graph. You just have to choose which one is correct. Okay. I also could ask you a question specific on these about the x-intercepts. Okay, do you see where these guys cross the x-axis? They also cross the x-axis at 2 different points. So if this one was slid over here, but it was much thicker, then you would have to find the x-intercepts, okay? So how you would do that if you wanted to find the intercepts. So you narrowed it down. So let's say you narrowed it down to 2 graphs, but they have the same vertex, but they cross the x-axis at 2 different points, okay? You're going to set your function equal to 0. X squared. Oh, wait. I'm sorry. I was looking at the next problem. 0 equals negative 1x squared minus 4x plus 5. Okay, we don't want our x squared to be negative, so we're going to move everything over. So we're going to say plus 4x minus 5 equals 0. Going to factor it. It's an easy trinomial with different signs. And you will have 5 and 1. You'll set both equal to 0 and then solve. Okay, so it should cross at negative 5, 1, which it does right here. Negative 5 and 1. Okay, which makes sense because that's the one we picked. All right. Okay, let's look at this one. Again, A equals positive 1. So the graph opens up. In our choices, this one opens down. So we know that one's not going to be it. And so does this one. So it's going to be either of these two. And again, these have 2 different vertices. So let's find the vertex and then we'll find our answer. Negative b over 2a equals, b is negative 6. So we'll have 6 over 2 times 1, which is 6 over 2, which is 3. Then we're going to plug 3 in to our function, and we'll get 3 squared minus 6 times 3 plus 8 is 9 minus 18 plus 8. So we get negative 9 plus 8. It's negative 1. Okay, so our vertex is 3 comma negative 1. So we have this one, 3 comma negative 1. Okay, this one is -3, -1. So it's not it. And we found it, right? You could find intercepts that same way. If those vertices were the same and you needed to still find it, you would say 0 equals x squared minus 6x plus 8. You would factor it, find the intercepts, okay? And they are 4 and 2. Which makes sense because in our answer, they cross at 4, 2, and 4. Okay. So, whoops. For this, all about parabolas, section 3.1 is all about parabolas. And this page is really the key. Okay. So if you know this page, you can do whatever I ask. Either I'm going to give you a function, I'm going to ask you all those questions, and then you'll graph it. Main thing is your vertex. Okay. Can't do much without your vertex and your axis of symmetry, right? Or I can give you some multiple choice where I give you the graph, give you some graphs, give you the function, and say which one is the correct one. And those are going to be easier because we can do a little bit of deduction there, a little bit of, I'm looking for a word, process of elimination. That's it. A little bit of that to get our answer. Okay.